Welcome to The Explainer. You know, every single app you use, every website you visit, it's all the result of a huge, complex construction project. So today, we're going to break down the blueprints, the recipes that teams use to build the software that pretty much runs our world. And that really is the million-dollar question, isn't it? I mean, when you've got dozens, sometimes hundreds of people working on millions of lines of code, how do you make sure they're all building the same thing? How do you prevent it from all just descending into chaos? Well, the answer in a word is process. It's all about having a deliberate recipe to turn that chaos into creation. So, here's how we're going to tackle this. First, we'll talk about what a software process even is. Then, we'll look at 3 classic flavors of development. After that, we'll break down the anatomy they all share, and finally, we'll see how the best processes learn to embrace constant change. Okay, let's dive right in. What is this foundational concept, this recipe that brings order to the otherwise chaotic world of creating software? It's actually pretty simple. You can think of it like this. Without a process, you've just got a bunch of really talented people writing code. But with a process, you have a team building a product. It's that shared blueprint, that common recipe that aligns everyone's work toward one single goal. Now, these recipes, they pretty much all fall under one of 2 big philosophies. On one side, you have plan-driven processes. This is where you try to map out absolutely everything in advance. And on the other side, you've got agile processes, where the planning happens in smaller, more bite-sized chunks. The truth is, in the real world, most projects are some kind of mix of both. Okay, so keeping those 2 big ideas in mind, planning everything up front versus planning as you go, let's look at 3 classic recipes that software teams have been using for decades. First up, we've got the original, the classic, the waterfall model. And you can really think of it like a literal waterfall. Once the water goes over one edge, there's no climbing back up, right? It's the same idea. You have to finish every single requirement before you can start the design. Then you finish all the design before you write a single line of code, and on it goes. So what's the big trade-off here? Well, the rigid structure of the waterfall model is actually great for massive projects where you need to coordinate a whole bunch of different teams. But its main weakness, its Achilles heel, is that it's just not flexible. It really only works when you know exactly what you need to build from day one. And let's be honest, how often does that happen? So to fix that whole rigidity problem, the incremental model came along. Instead of one giant waterfall, you build the software in a series of small, manageable waves or increments. This means you're mixing up the steps of defining, building, and testing, and the benefits are huge. It's way cheaper to change your mind, you get feedback from customers early and often, and you can get useful software into their hands much faster. But of course, this model has its own set of challenges. Because things are moving so fast and in so many little pieces, it can be tough for managers to see the big picture and track overall progress. And if you're constantly changing things, the code's underlying structure can get really messy over time. To fight against that, teams have to spend time cleaning up the code without changing what it does. That process is called refactoring. All right, our third flavor is a little different. It's less about how you build and more about what you build with. This is the reuse-oriented model. The whole idea is to assemble software from parts that already exist. Things like open source libraries or what the industry calls COTS, commercial off-the-shelf systems. It's kind of like building with high-tech Lego blocks instead of making every single brick from scratch. The upside here is pretty obvious, right? It's cheaper, it's less risky, and it is way faster. But the downside is that you have to be willing to compromise. That pre-built component might only do 80% of what you need it to do. Plus, you give up control. If the person or company that made that component stops updating it, well, you could be in a tough spot. So we've just looked at 3 very different models. But what's really interesting is that no matter which recipe you pick, they all share 4 fundamental activities. They're like the core ingredients. First up, you have specification. This is the what phase, and it's absolutely crucial. Before anyone even thinks about writing code, you have to define exactly what the system is supposed to do and, just as important, what it's not supposed to do. Next up, you take that specification and you start to bring it to life. This is design and implementation. It's where the software architects plan the overall structure and the programmers get to work writing the code that turns that blueprint into a real working system. The third activity is validation. You can just think of this as checking your work, and it's really a two-part test. First, did we build what we said we were going to build? And second, this is the more important question. Does this thing we built actually solve the customer's problem? And this right here brings us to a super important distinction that can literally make or break a project. You've got verification, which asks, did you build it right? Meaning, does it match the plan? But then you have validation, which asks, did you build the right thing? See, you can perfectly follow the wrong plan. Passing verification but failing validation, that's how you get beautiful, well-coded, and completely useless software.
And last but not least, we have evolution. Why? Because software is never really done. Customer needs are always changing. Technology is always advancing, and the system has to be updated and modified to stay useful. It has to evolve, or it will die.
You know, that idea of evolution is so critical that it leads us straight into our final section. If we know for a fact that change is going to happen, how do modern processes actually cope with it? Here's the one universal truth of making software. It is never, ever finished. The world is always changing. Business goals shift. Brand new technology appears out of nowhere. The platforms we build on get updated. So change isn't just a possibility, it is an absolute guarantee. So if change is inevitable, how on earth do you prepare for it? Well, one of the most powerful tools in the toolbox is the prototype. This is a quick and dirty early version of the system. It's not supposed to be perfect. Its only job is to make an idea real enough to test, so you can make sure everyone is on the same page before all the really expensive work begins. And the payoff for doing this is just huge. By getting a rough version of your idea in front of real users early on, you can work out all the kinks in the design, you can make sure you're actually meeting their needs, and you end up saving a ton of time and money when you build the final version. But, and this is the crucial lesson here, and it might feel a little weird at first, the value of a prototype is in the learning, not in the code itself. They are meant to be thrown away. Why? Because to build them fast, you take shortcuts. They're often undocumented, and they just don't meet the quality standards you need for a real production system. You learn from it, you toss it, and then you go build the real thing the right way. So after all of this, what's the big takeaway? It's that there is no single, perfect, one-size-fits-all software process. It just doesn't exist. Waterfall, incremental, reuse-oriented, they're all just tools in a toolbox. The real challenge, the real skill for any software team isn't finding the one true recipe. It's understanding all the trade-offs and knowing how to choose the right recipe for the specific job at hand.